Watch, learn, and we'll be a star freelancer. 24-hour live stream. Save time and money. 100+ free videos and free books with source code, materials, and resources. Starfreelancer.eu.
Welcome back. In this lecture, we are going to get a very high-level introduction about what are Fargate profiles and what is Fargate, and then what is this Fargate serverless. So as part of this section, we are going to add our new feature to our EKS cluster, which is Fargate profiles. So let's move on and understand on a very high level what is Fargate. So Fargate is a serverless compute platform for containers on AWS. So Fargate provides on-demand, right-sized compute capacity for our containers. So EKS integrates Kubernetes with Fargate by using the controllers that are built by AWS using the upstream extensible model provided by Kubernetes. So these controllers run as part of EKS managed Kubernetes control plane and are responsible for scheduling native Kubernetes pods onto Fargate. So the Fargate controllers include a new scheduler that runs alongside the default Kubernetes scheduler, in addition to several mutating and then validating admission controllers. So these 4 points are very important on a Kubernetes perspective on EKS in relation with Fargate. So these 4 points I directly took it from documentation and then pasted here. So the reason is like, so when we want to understand how Kubernetes is scheduling the pods on Fargate related serverless infrastructure, the answer is we have the Fargate controllers created by AWS using this upstream extensible model, and due to that it is able to schedule the pods on the Fargate serverless platform. So when we start a pod that meets the criteria for running on Fargate, the Fargate controllers running in the cluster recognize, update, and then schedule the pods on the Fargate. So that's about the Fargate on a very high level. But the key point in this slide is we are going to have Fargate controllers inside our EKS managed control plane, which is built using upstream extensible model provided by Kubernetes for scheduling the pods on Fargate. So that's the key point here. Moving on, so AWS EKS on Fargate. So let's understand what we are going to get using that. Okay, so we can directly bring our existing pods and then deploy to Fargate without any hassle. So we don't need to change our existing pods. So Fargate works with existing workflows and services that run on Kubernetes. No changes, straight away you can bring and then deploy here. But there is one condition. The last slide of this lecture will have something called considerations. So very, very important thing. So when we are running things on Fargate, so how we say bring and then run as easily, at the same time there are some architectural decisions and then what it supports and then what it doesn't support also provided by AWS, and that is a big list. Okay, so that one also we need to see. Those are called Fargate considerations. So we also need to have a knowledge on those things if we want to bring our applications to run on Fargate. So next thing is they are production ready. So now EKS Fargate is production ready. So we can launch pods easily to Fargate, and it runs pods across availability zones for high availability, and each pod runs in an isolated compute environment. So this is a very important point from Fargate perspective. We will multiple times stress this point in our course in the next upcoming hands-on lectures, stating that one pod is equal to one EC2 Fargate instance in our EKS. So whenever we launch a pod, it is going to generate a EC2 Fargate instance automatically in the background. And whenever you say kubectl get nodes, whenever you have deployed 5 Fargate pods, then you will get 5 EC2 Fargate worker nodes available for you. And then you can see that using kubectl get nodes. And next thing is right-sized and then integrated. So this is something like how much you need, use that much only. So if my pod needs these many resources, then use that much only. So only pay for resources you need to run your pods. So it also includes, means like Fargate also includes AWS integrations for networking and then security. So networking and security is not compromised by using Fargate on EKS. Moreover, your security is doubled only, we can say, not reduced. Okay. So now EKS deployment options available for us. Okay, when we bring Fargate into the picture, so what all deployment options EKS is available, if we take a look on a very high level, that looks great. Okay, so that's the reason I have put this slide. Okay, so we can have only EC2 node groups which are managed or unmanaged, or we can have a mixed deployment with the EC2 managed node groups, EC2 unmanaged node groups, and then Fargate, or only Fargate cluster, means like only a cluster, EKS cluster control plane with Fargate profiles can be created. So you can see EC2 node groups with managed EC2 and then unmanaged EC2 nodes. And if you see, overall our entire this course will be dependent on managed EC2 nodes and Fargate profiles. So we really didn't do anything related to unmanaged EC2 nodes, wherein you need to bring your own AMI and then your own AMI, and then you need to manage it using EKS control plane. And this is legacy, and then this is the trend which is running now, which is managed EC2 nodes. So we focused on this one primarily, but as this option is available, so I just put it here. Okay, so now the next thing is managed nodes, unmanaged nodes, and then Fargate nodes in the mixed mode. And in Fargate you can only have Fargate nodes. In simple terms, Fargate serverless. Okay, so you don't even need to say nodes here. Okay, and next thing is in deployment options, when you have EC2 node groups. Okay, primarily we are focusing on managed node groups only. Wherever I say node groups, it is going to be managed node groups. Okay, so in a AWS cloud, whenever you create a EKS cluster, it is also going to create a VPC. And when we create a managed node group, as part of that, so you can create your managed node group in public subnet, or you can create in private subnet. So this flexibility we have when we are dealing with EC2 instances. So you can have your managed node groups created in both public and then private subnets and then handle that. So but when we go to Fargate, you'll have a restriction there, so we'll go there and then see it. So in only Fargate mode, so we are going to have our respective Fargate profiles get created only inside private subnet. So pods running on Fargate are only supported on private subnets. In that case, whenever you have a EKS cluster, and then whenever you want to deploy your loads on Fargate, in your cluster at least one private subnet should be there to create your Fargate profiles. And moving on, so how the mixed mode deployment looks like. Okay, so you can see that in mixed mode, so you will have the EC2 instances in private and then public subnets, and then you can create your public and then private managed node groups there. And then for Fargate, you definitely need to force yourself to create your EKS Fargate profiles in your private subnets. And moving on, EKS Fargate versus managed versus unmanaged nodes. So this is one thing which AWS highly portrays, and this simple thing makes us understand many stuff here. Okay, so one is units of work. Okay, so in units of work for Fargate, it is just only a pod, so it is concerned with only a pod. So whenever you deploy a pod, it is going to create a new underlying Fargate EC2 instance, but it concerns about only a pod. But in managed nodes, we first create EC2 instances and then we deploy our pods in them. And in unmanaged nodes also it is the same thing. And units of charge means like how the billing happens. Okay, so here in Fargate it is going to be pods. So when you are dealing with multi-tenancy environments and then you want to charge for specific clients per pod, means like they have few pods running and then for them you want to charge, this is one good option for us. Okay, and in the charging perspective in managed nodes is going to be based on the number of EC2 worker nodes. In unmanaged also it's the same. And host life cycle. Okay, so there is no visibility of the host from Fargate perspective. So visibility in the sense you will not be able to connect to that host. Visible in the sense, if you say kubectl get nodes, so this forget nodes also will be visible for us. Per pod it is going to span one node, right? So but ideally we don't have access to that nodes, okay? So they can terminate and then recreate, or what is happening inside that node is not our business. Only our business is what I'm going to deploy from pod perspective in forget. But in managed nodes, so we'll have the AWS SSH is allowed in the managed nodes. So whenever we are creating the cluster also, we are giving a tag there to provide SSH allow and then access and then key pair information also in our node group creation command, whatever we have seen so far. And in unmanaged nodes, so the host life cycle is customer dependent. Okay, so we really don't care here. Okay, so which means AWS really don't care about what you are going to use and then how you are going to handle your authentication authorization about your host. And in host AMI perspective, so we really don't have any visibility about the host AMI in our forget, because we are not even able to log in, or we are not controlling that. Okay, but in managed nodes, it is AWS vetted AMIs will be provided for us, and then they will be patched, auto updated from AWS for us. Okay, so that's the reason that is called managed nodes. And from unmanaged nodes perspective, customer bring your own thing. Okay, so which means including the OS also you need to bring, and then just use the EKS cluster control plane with that. So lot of hard work we need to do. But why do you use unmanaged nodes, right? So that's based on, means like it's a legacy, and then recently they introduced the managed nodes, and then we can start using managed nodes. So now host to pods relation. So this is very important for us to make a note from forget perspective. So one forget host is equal to one pod. So if you span 10 pods, then it is 10 forget hosts. Okay, but in managed nodes you can have 2 instances, and then you can span many pods based on the CPU and then memory resources available in those nodes. It's the same case, one to many in unmanaged nodes. So that's about the forget versus managed versus unmanaged nodes. And next thing is forget considerations. Okay, so these are very big. So what we need to do is we need to take this documentation link and then review them. So there are many considerations we need to be aware of before we decide our Kubernetes workloads to run on forget. Okay, so that's very important here. So let me copy this link and then go here and paste it. Okay, and if you see here the considerations, right, so let me make it bigger, right? Okay, this looks good. Okay, so these are the forget considerations we need to worry about when we are dealing with it. Okay, so when you see here, the first thing itself is the thing, classic load balancer and network load balancer are not supported on forget. Only application load balancer with ALB ingress is supported. With the minimum version it should have this one. This is one thing. And like this, there are many things. Okay, daemon sets are not supported, so you can go through all this stuff here. So as we have documentation link, whenever you are deciding your real production workloads planning to run on forget, so you need to go through all these things. Currently GPU is also not available, and privileged containers you cannot run, and daemon sets are not supported. So like this, there are many things. Pods running on forget need to only run on private subnets. Okay, you can use the vertical pod autoscaler to initially right size the CPU and memory for your forget pods, and then use the horizontal pod autoscaler. Okay, so stateful applications are not recommended for pods running on forget as on today. Okay, they doesn't have a persistent database. Okay, persistent disk. So for that purpose, these are not allowed. Okay, so like this, many things are there here, so which you need to go through and then understand, and then based on that only decide if your workloads can run here, your production workloads can run on forget or not. So that's about the overall forget introduction. Okay, so we'll continue to the hands-on section in our next lecture. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about forget profile basics, right? So far we have learned about classic load balancers, network load balancers, application load balancers, and then certificate manager, Route 53, Elastic Block Store, and then RDS in combination with Kubernetes and with the Elastic Kubernetes service on AWS. So now we are going to start with Fargate profiles. So it is going to be divided into multiple sections so that we start with basics and then move on to advanced sections of Fargate profiles. So if we go here in our 0901 Fargate profile basics, so as a step 1, we are going to understand what we are going to learn as part of basics. So assumptions here are, we already have a EKS cluster whose name is EKS demo 1, and then we already have a managed node group running there with EC2 instances. So now we are going to add additional Fargate profile here. So which means we are going to run the cluster with a mixed mode, in the sense like we are going to have managed node groups and also we are going to have Fargate profiles. So we are going to create a Fargate profile using our tool CLI named EKS CTL. So we are going to deploy a simple workload with Nginx app1 as the application, and then its equivalent node port service will get created. And for creating the load balancer, we are going to use ingress service, and in addition to that we are also going to DNS register that using external DNS in Route 53. So in addition to that, we are also going to learn about new annotation for ingress, which is target type IP. Okay, so why we are going to learn about that is because Fargate doesn't have a dedicated worker nodes, so that dedicated EC2 type of worker nodes, which we can leverage for node port services, which we have used for application load balancers earlier, right? So for that purpose, we are going to directly use the pod IP to be registered to the load balancer target types. So we'll see more in detail when we go inside. But so let's go back to our presentation once, and then if you see, we already discussed about mixed mode in our introductory section, but we'll see the picture one more time. So we have a EKS managed node group with 2 instances in a private subnet currently. Okay, so but the depiction here we are also showing with the public subnet, because managed node groups which we can create on EC2 instances, we can create in both public and then private subnets. But when coming to Fargate case, so we are going to specifically tell that, so we can only create Fargate profiles in private subnets. So Fargate profiles can be deployed to EKS clusters only, at least we have in our EKS cluster 1 private subnet. So these cannot be deployed to the public subnets. So that is very important point which we should be aware of. So we already said that in private subnet we already have managed node groups running, right? So let's go ahead and then see that. So for that, kubectl get nodes -o wide. Okay, and if you see, we should have 2 nodes running here, and their internal IPs is 110.114 and then 85.8, but you can see there are no external IPs for these nodes, because so those are deployed to this private subnets. So now we are going to create this respective Fargate profile and then run the stuff here. Moving on, so let's see what we are going to do, right? So as part of EKS cluster, already NAT gateways and then public subnets and then private subnets are created in respective availability zones, right? So now we are going to create a Fargate profile fpdev with the namespace also fpdev, right? And then going to deploy a application named app1 nginx. So we have deployed it and then it created a replica set. So once it starts creating the pods, those pods will be scheduled by automatically creating the Fargate nodes. So Fargate nodes will get created and then these pods will be scheduled on those respective nodes. So we have given in our manifest replica as 2. So it is going to create 2 Fargate nodes. So here one thing we need to understand here is, in Fargate, so the number of hosts is directly proportional to number of pods. So if you give 10 pods in your replicas in your deployment, so obviously you are going to get created 10 Fargate nodes. So now moving on, we are going to also automatically have a outbound connection to the EKS cluster plane for these Fargate nodes via NAT gateways. The next thing is, its equivalent node port service also will get created. So when we are doing the complete mixed mode with multiple applications, few on worker nodes and then few on Fargate, then these node port services will be very helpful, where we are going to define target type :IP as the annotation at the service level also, as and when required. So now we are going to create the ingress service, means like whatever the manifest we created, it is going to create a ingress service with SSL redirect, external DNS, everything, and then it will also associate the SSL certificate created here and enable the SSL redirect, and also DNS register the fpdev.kubeoncloud.com for using external DNS. And then whenever user tries to access fpdev.kubeoncloud.com/app1/index.html, so it comes to application load balancer, and for the /star it is directly going to the pods. So there is no node port service in between. So from application load balancer target types, it is going to directly go to the respective pods whenever we use the target type annotation with IP. By default, it is going to have target type is equal to instance, which we really don't need to define because it is default. So now let's go back to our GitHub repo. So and then move on with the prerequisite steps. So one thing we need to understand in prerequisites here is EKS CTL CLI. So this is very important thing. So EKS CTL will have continuous releases with new feature additions every 15-20 days. So it's a very high evolving space nowadays in AWS, means like EKS CTL and also Fargate related stuff. So that is the case, even though means like whenever you have started and then implemented this, so you might have installed some version here in our 01 EKS create cluster using EKS CTL. And now whenever you are doing maybe 15 days over and then again you are trying with different things in your course, go ahead and then update your EKS CTL. So every 17 to 20 days they have upgrades to the EKS CTL with lot of new features coming into the place. So always it is recommended to use latest version. And then this is the releases page where you can browse to see latest version. And EKS CTL version will provide you the exact information about what is the current version. I have also updated the report to check your version, and then accordingly you can cross check in the EKS CTL releases what is the latest version and then update it. So this is only a prerequisite and then cautionary step for you. Okay. And now moving on, prerequisite check about ALB ingress controller and then external DNS, right? So now if we go back to our PowerPoint here, so whatever you deploy in these private subnets, whatever the workloads you deploy, how are you going to expose it to the internet to test your application, right? So because this Fargate nodes doesn't have any concept of node port service, so even though if you create the node port service, so that node port information is not there because it doesn't have a static node which supports these node port things, right? So even if you define a cluster IP service, it will be restricted to your cluster, but you cannot access at the internet level. So that's the reason you need to have the user or whatever the related load balancer created here. Okay. So I am just saying here user management load balancer only because anything is fine, right? Manifest things I am not going to change too much because upcoming again next lectures anyway we are going to add the user management stuff. Okay. So but some load balancer we are going to get created here for our app one, right? So whatever we are getting created here, those needs a few prerequisite services, right? Example, if you want to create a application load balancer via Kubernetes, you need to have the ALB ingress controller installed. In the same way, if you want to register your DNS to Route 53, you need external DNS should be available. So we need to ensure that those are available for us on our current worker node. As part of previous sections, we are anyway continuing the same cluster EKS demo one. Those should be available for us. So we have verified kubectl get nodes -o void. So we are going to verify kubectl get pods -n kube system to see that our ALB ingress controller pod is running, right? So our ALB ingress controller pod is running, no issues. So we'll also verify get pods in default namespace where our external DNS pod is running. So if these two are there, then only our this respective load balancer, whatever we are going to create for these app we are deploying in Fargate is going to get created and then DNS registered in Route 53 successfully. So we verified all our prerequisite steps also. In our next lecture, we'll focus on creating forget profile and then deploying the stuff and then testing it. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to create a forget profile on our EKS cluster, EKS demo 1, right? So before that, we are going to verify any forget profiles exist. So EKSCTL get forget profile in cluster EKS demo 1. So let's go ahead and then verify that now, right? So I'll go back here and then I'll say clear and I'll paste it, right? So if any forget profiles are there, it is going to list for us. No forget profiles found. So we are going to create a forget profile. So the template is -- cluster EKSCTL create forget profile and cluster name and the forget profile name if we want to use and the namespace whatever we want to use, right? So namespace is the core thing here, which is nothing but if our application is deployed with this namespace, automatically that respective application's pods are going to get scheduled under this forget profile. So what we are going to do is we are going to copy this and then paste it, right? So the namespace tag whatever we provide is the critical. So if our application deployments have a namespace reference to fpdev, means like our deployment related manifest has fpdev, then that respective pods inside the deployment are going to reference and then deploy on this respective forget profile. So as soon as forget profile is created, so there will not be any instances present there. Only when we deploy the workload, which means the deployments, then only the forget instances will get created. Okay. So let's wait for this profile to get created. So we can see that forget profile got created. So one important thing here is when you are going to create this forget profile first time, right, in your respective EKS cluster where you already have existing managed node groups running, right? So at that point, it is also going to create a forget pod execution role also. So at that time, you are going to see this type of output. So already this is created when I am testing for different things. So this output you didn't see now. Okay, so you said you have seen that it tried to create it and then finally created it. Okay, so that's all. But ideally, it also will create a forget pod execution role as part of whenever you create your first forget profile inside your cluster, right? So now let's move on and then review the manifests as part of whatever we are going to deploy to our forget profile, right? So we are going to deploy a simple Nginx app1 with Ingress load balancer. So we cannot use worker node ports for forget pods for two reasons, right? Forget pods are created in private subnets, so no access to internet to access them. So forget pods are created on random worker nodes whose information is unknown to us to create a node port service. That is also another important thing. But in our case, when we are doing the mixed mode environment with node groups and then forget, if we create a node port service with Ingress load balancer and then there is no target type of IP related annotation, still things are going to work because the node port service whatever you have created is going to also present on managed node groups also. As part of that, you will get the worker node ports from managed node groups. So that is not a good option, and always it is recommended for forget loads to use target type is equal to IP as the annotation at the Ingress manifest level, or if we have a mixed mode multiple applications deploying, for that respective application who needs IP related target type on our application load balancer, you can use IP. So now the first thing is to create a namespace manifest for us. Okay, so we usually give 01 or 00 for our namespace manifest, and namespace is the mandatory one for our respective applications. We need to map to that respective namespace, then only they can be deployed or scheduled to that forget profile. So now we are going to create a API version v1 kind namespace, and the name is fpdev. So let's go back here, and if you see the namespace 01, namespace. In 0901 forget profile basics, you can see 01 namespace. So this is there. And the second one is update all other manifests with the namespace whatever we are creating. So one is Nginx app 1. So if you see it here in its deployment manifest under the metadata, you can see namespace fpdev is added. In the same way, its equivalent node port service also under the metadata namespace fpdev is added. So rest all health check URL, all those things we are not changing, which is coming from previous examples only. Okay. So only namespace added with fpdev. One more is ALB ingress SSL redirect with the external DNS, whatever we have implemented earlier, right? So in our previous section, the same thing. And here also under metadata section for ingress service, we have added namespace fpdev. In addition to that, we are also going to add for our deployment manifest, right? So we are going to add resources section. So why this resources section? So this is another important thing. So in Fargate, it is super highly recommended to provide the resources.requests and then resources.limits about our CPU and memory in our deployment manifest. So almost you can make it as mandatory. Okay. So 100% we need to use this. That is the good option. Okay. So this will help Fargate to schedule a Fargate host accordingly. Means like the Fargate host, whatever it is going to create for that pod to be hosted there. So how much resources that Fargate host need to have will be decided based on how much you provide inside this request section. So it's not going to use whatever you provide here. More than this only it is going to allocate, but there will be some calculation here. Okay. So it will take this much. Example, you take memory 128 MB you are giving, and it is also going to allocate plus 256 MB for its kubelet and then Kubernetes related core things to run on the worker nodes, right? So for kubelet and other things, and then accordingly it will decide the value and then provide the memory for our Fargate host. So in addition to that, as Fargate follows 1:1 ratio host to pod, 1 pod per host concept, we defining resource section in pod template, right? So deployment pod template spec should be our mandatory option. Even if we forget to define resources in our deployment template, low memory using pods like Nginx will come up and then keep running. Okay, so those will not have any issue most of the time. But high memory using apps like Spring Boot, REST APIs or anything, it will be in the continuous restart mode in your Fargate profile. So which is not good. So always recommended to use resources section. So let's go back to our Nginx app1 deployment section. And you can see we have added the, even it is Nginx, I have added it right in the pod template spec. So under containers, and then for this you are adding the respective resources for this container. For this container, it needs this much information of resources to be allocated, or it requests for this much information and it can go for this limit whenever it needs. So that's about it. So in addition to that, update ingress manifest with ALB ingress Kubernetes target type is IP. So as we already discussed multiple times about this one, as we are running our pods on Fargate serverless, we need to change our target type to IP, because we really don't have any dedicated worker nodes here. Okay. So now in addition to that, we'll also update our DNS name to fpdev.kubencloud.com. So let's go to ingress manifest. And you can see here, this is already added, and external DNS name also I'm going to say fpdev.kubencloud.com. So one thing important here we need to note is like this can be defined even at the service level here. Okay. So you can even define it at the service level based on our set of applications. So in this ingress, you have few applications with EC2 worker nodes, and then you want to go with node port service for them, and few applications with Fargate and the same ingress service you are planning to use. So few with worker node port, and then few with the instance IP if you want to use, then you should not define this here. Okay. So for all the Fargate deployment related things, we can take this IP and then put it in our respective node port service annotations, and we can leave the default, which is target type as instance for other related worker node stuff. Okay. So that for deployments related to which we are going to host on managed node groups, they directly get the node port related stuff automatically. Okay. So this completes the review of our manifest and also about this creation of our all these forget profile. So in our next lecture, we'll focus on deploying these things and then testing. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to deploy our manifests and then test, verify whether they are scheduled on forget, and we are also going to test it using the URL. So let's go back to our command line and then go to 09 and 0901 section, right? And we have the kube manifests here. Okay, so I am going to say kubectl apply -f and then kube manifests, right? And all the manifests present in that should be created. So we have the fp dev created, app1 nginx deployment got created, node port and then ingress got created. So right, so first we will verify our get namespaces, which is ns, and our fp dev namespace got created. So we are also going to verify get pods, right? And then -n, which is nothing but in fp dev namespace, and -o wide, so that it will also provide the node information. So it is trying to get 2 pods related to it, and then nominated node, still we didn't get the name of the node, but that's fine. It will take a while to get the name. So it's currently in the pending status. So once the node is ready, then it will go ahead and then schedule immediately, right? So we can go back here and then get nodes -o wide. So let's see how many nodes are there in our cluster now. So earlier you have seen only 2 nodes which are starting with IP, right? With internal, this one, these 2 nodes, okay, 110.114 and then 85.8. So they start with IP-, but forget nodes start with forget-IP. So we have the 2 replicas created as part of this deployment, which means we said that 2 replicas, so 2 forget nodes got created. So let me clear this, and I'm going to verify the pods one more time. kubectl get pods -n fpdev -o wide, right? So these are scheduled inside this and then running, right? So I'm going to say kubectl get ingress from namespace fpdev, right? So it got created, means like if this name, this address field is having the value, which means it got created, means like there is no issues related to it. So let's go back to our AWS management console and go to EC2 service, right? And let's go to load balancers, right? And in load balancers, so we have that application type load balancer is getting created. And if you go to listeners in port 80, we can see that the redirect thing will be there, which standard, which we have seen earlier also, HTTP to HTTPS. And in port 443 for /* you should have a /*. Why? Because in ingress we have defined /* only, right? So why? Because this is app1, only one app, right? So I said /* here. So it is going to one target group. So I can directly click here to go to the target group, or I can go back and go to target groups here, and then I can open the target group here. So before opening it, you can see target type is not instance here, it is IP, because we have used the target type as IP, which means it is directly going to the pod IP. So I'll open this, and this is the HTTP related health check path, and this is the target, and they are healthy from the both nodes. You can see 158 and then 107, right? So I'll say kubectl get pods -n fpdev, right, -o wide, right? So you can see that our pod IP and our node IP in the forget is going to be same. You can see 107 and then 158 related IPs. You can see here them. Okay, so that's about creating it. So now if our let's verify also the route 53 stuff, right? So fpdev got successfully registered or not. Code on cloud.com. So let me close this, go to hosted zones, and you can go to code on cloud, and if you see it, we have the fpdev.kubeoncloud.com got created. Okay, so I'll also do ns lookup to verify fpdev.kubeoncloud.com, right? So it's working. So let's go back and then access the URL and then test it, right? So I'll go to browser and I'll say this, and it's working as expected, right? So everything is working. So now let's go ahead and then delete our Fargate cluster. So I'm not doing anything related to application is running here, and then I went and then deleted the Fargate cluster. So let's see what happens. So first list the Fargate cluster, right? And then get the name and then delete it. So already we know that our Fargate profile name is fpdemo. I can directly say EKS delete Fargate profile from cluster EKS demo 1, and the Fargate profile name is fpdemo, and then also provide wait statement. Okay, so wait statement will allow us our command line to wait here until the deletion is completed. So it is nothing but fpdemo. We can see the name here, right? So and inside that the selector namespace is going to be fpdev. So I'm saying EKSCTL delete Fargate profile cluster EKS demo 1, and the name of the Fargate profile is fpdemo, and then wait, right? So it will take 2 to 3 minutes to delete it. Until then I'm going to pause the video. So it took close to 4 minutes to delete the Fargate profile. So let's verify, means like earlier our app nginx related deployment pods are present on Fargate nodes, right? So now kubectl get pods -n fpdev, which is nothing but in namespace fpdev, and then -o wide, right? So let's see what happened to them, right? So now if you see, those are still present and then scheduled on your regular worker nodes, which is nothing but your EC2 private node group. So they got scheduled on our if we go back here, so it got scheduled on these things, right? So it got scheduled to this private subnet. So when you deleted this Fargate profile, automatically those got scheduled here. So that's about it. So which means like it didn't delete the application or anything, only the Fargate profile got deleted and the application came back to our original EC2 worker nodes. So now if we want, we can even access the application and then it should be running, no issues. So I'm saying enter one more time, no issues. So I'll take it and then put it on file, new private window, and then access one more time, right? Just for safe side. So everything is working fine. So this completes this respective section, which is basics. And in addition to that, if you want additional information, there is a references section here. Okay, so eksctl.io usage Fargate support. So here also you will have good information to follow. In addition to that, you will also have Amazon documentation, and for ALB ingress controller related annotations related to target type, right? So you can find here. Okay, so this is the from last third one here. Okay, so you can even have it with instance or IP, and instance is the default, and you can have them on ingress or service. So let's go ahead and then clean up the stuff whatever we have created so far, right? So kubectl delete -f kube manifest. Okay, so I can copy this and let's go here in 0901 Fargate profile basic, delete whatever we have created, so that all the ingress manifest, load balancers, everything will go away, and then it will not cost us any money for us. Welcome back. In this lecture, we are going to understand about Fargate profiles creation with YAML. So let's see what we are going to learn all in all. So we are going into inside 0902 Fargate profiles advanced YAML. So as part of this, what are we going to learn is, so we are going to deploy 3 apps in a mixed mode deployment. So which means one app to our EKS managed node group, which is with EC2, and two apps we are going to deploy to two different Fargate profiles. So as part of that, to create those two Fargate profiles, we need to write the YAML and then create those two Fargate profiles at a time. Earlier, we have used the command to create it in our 0901. So to create a Fargate profile, so we have used the command. So like this, if you want to create 10 profiles, so you need to run 10 times the command. Instead of that, we are going to do that using a YAML file. So like this. So we'll discuss about this later, but for now, we'll go back and then understand what are the three apps and then how we are going to deploy the detailed architecture. Let's see what are those three apps and then how we are going to deploy in a visual manner, right? So in AWS Cloud, we have a VPC, and inside VPC, we are going to have both the EKS managed node groups and then EKS Fargate profiles. So in a EKS cluster, we are going to have both Fargate profiles and then managed node groups together. So that is nothing but we call it as mixed mode, right? So what happens here is like, as usual, we'll have our availability zones and then subnets, right? So from Fargate perspective, it only supports private subnets. So if you see here we have only private subnets, and managed node groups can be created in both private and public subnets. But as part of this section, we have already an existing private subnet related EKS managed node group. So that's the reason I have rounded it to only this part. And in these public subnets, we are going to deploy our ingress related services. So now what happens is, as part of Fargate, whenever we bring the Fargate into the picture, so the organization of apps is going to be with the namespaces, right? So how we are going to organize this with namespaces. So for this EKS managed node group, whatever the application NS app1 means, like app1, whatever we are going to deploy, for that we have created a namespace NS app1. In the same way, for app2, we are going to create a namespace app2. And then for application UMS, which is user management microservice, so we are going to have the namespace as NS UMS. So now NS app2 will be part of one Fargate profile, NS UMS will be part of another Fargate profile, and NS app1 is going to be for managed node groups. Means like these namespaces are not tied to anything specifically. So but high level, if we have that namespace tied to Fargate profile, so those apps will be scheduled to that respective Fargate profile. So it's the other way around. But whatever may be the case, so now if we take my app1, right? So app1 related pods I have deployed on the EC2 worker nodes here. So, and it will have its own node port service and its own app1 ingress service. Okay. And in the same way, for app2, we'll have a Fargate profile with app2, and then inside that we'll deploy our app2 application, and it also will have its own separate app2 ingress service. So why we are having separate set of services, we'll see in the next slide. Means like why we are going to have separate ingress services here. Okay, so we have seen the concepts of context path based routing in ALB. But why we are not using here when we are using this mixed mode deployments? Okay, so there is a reason for that. So we'll see in the next slide. Okay, so now another thing is UMS. UMS is nothing but user management microservice. Its ingress service need to be deployed, and UMS pod, which is nothing but UMS deployment, will be deployed, and its node port service and its external name service, and this external name service is going to connect to the RDS database, right? So whatever we have created. So if this RDS database is not up and running from previous sections, whatever we have created, right? So if it is down, and then if you want to start it, you can start it up. Okay, why? Because whenever you deploy UMS, if this is not up, then this pod keeps failing. So now the next thing is, as soon as these things are created, one more thing will be there, which is external DNS to register the DNS names, and also associate for SSL certificate, certificate manager related certificate will be associated in our ingress service. Okay, so now it will register 3 DNS names: app1.kubeoncloud.com, app2.kubeoncloud.com, and then ums.kubeoncloud.com. So now as a user, so if I am using, means like if I am using app1kubeoncloud.com, and then if I access the application, I come to app1 ingress, and then from there I'll go to app1 node port service, and then from there it will be load balancer to app1 pods. Okay, using node port service stuff. Okay, so now if we go to app2kubeoncloud.com, it will go to app2 ingress here, and then we directly go to the pod, because we are going to use for forget pods, we are going to use target type IP in our manifest. In the same way for kubeoncloud.com, so we are going to access it, and the request comes to ums pod, and if the request is health status, then directly from here it will be served. But if the request is going to be something like list users or something which is /users, so then the request will go to external name service, and then it will go back to RDS database and then serve it back to the user. So this is the mixed mode with 3 apps, whatever we are going to deploy. Mixed mode, again I am going to reiterate, nothing but in a same EKS cluster we are going to have both forget profiles and then EKS managed EC2 nodes also in the same cluster. Okay, so that is nothing but the mixed mode. So moving on, so we have discussed about why can't we use the app only one ingress for all these things, right? So means like one ingress for app1 UMS and also for app2, and then route it. If it comes to app1 ingress, and then if it is /app1, go here, and then if it is UMS, go this way, and then app2 go this way. So why can't we do that? Okay, so which is nothing but ingress with cross namespaces, you call it as. Why? Because you created a ingress, and then this ingress, whatever you are going to create, right? So if you go back to the previous picture, right? So this ingress, whatever the app1 ingress, even though we are not specifying here in the picture, app1 ingress will be part of NS app1 namespace. Okay, and UMS ingress will be part of NS UMS namespace, and app2 ingress will be part of NS app2 namespace. Now if you see here, this one app1, this respective ingress, if it is not part of any namespaces, or if it need to go across namespaces to send the traffic, so that's not possible as on today, which means like ingress with cross namespaces is not supported as on today. Even there is a GitHub open bug from 2015 onwards, but till date that is not resolved as on today. So not only in ALB ingress, this is not supported as on today. So now, which means this concept is not applicable here. So always if we are dealing with multiple namespaces, then always it is like each namespace one ingress should be there, and inside this namespace you have 10 apps, then 10 context path based routing or host header based routing, whatever the routing you want to implement, you can implement inside that namespace. But outside of namespace, which means across cross namespaces with single ingress, we will not be able to do the context path based routing or any host header based routing or any ingress related concepts with single ingress to multiple namespaces. So with that said, we have completed our introductory section, and then we'll move on to advanced forget profile with YAML in our next lecture. So I'll see you in the next lecture. Until then, bye bye. Thank you.